So fancy. Alright, it's going to be about triangles. So let's write that definition down. Just to make sure we all have the same idea of what a triangle is. So if you do not have your notes out, take your notes out. This is a good refresh. If you're struggling through other chapters, this is a good refresh. Because we're starting on the first lesson. It's a good spot for everyone to jump in. You don't have to be good at any of the other chapters for this one. This one's kind of alone. Alright, a triangle is a closed shape. Does anyone know what I mean by a closed shape? It's locked in, yeah. Okay? We want to make sure that it's not open. We could make 3 sides. Decided you want to draw one on the board since you did one last time and it was just so good.
Mm-hmm. So I could still have 3 sides and have a shape like this. Is this a triangle?
No.
No. We would need to close this up, right? It's got to be a closed shape.
Okay, so it's a closed shape. How many sides does it have? 3. And when it has 3 sides, do they have to be straight or curved or... What do we know about the sides of a triangle? Straight, yep. So it has 3 straight sides. And how many angles are in a triangle? 3. Whoa. Tri means 3. Triangles. 3 angles. That's literally what the name means. Fun fact. It's totally a history lesson. Alright, so we're going to classify triangles in 2 ways. Our first way that we are going to classify triangles is by their side lengths. And there are 3 ways we can classify triangles by the side lengths. So I'm going to do 3 little columns here. Because we're going to do 3 options. Alright, so our first thing with 3 of the side lengths, and we just briefly talked about it with everyone, is we could have all 3 sides be different. So you might have one that's small, maybe one that's medium, and one that's kind of long. So I'm using 3 different colors to show that those are 3 different side lengths. They are all different. So if you want to use those color pencils, you can. They're in your bins. So, when 3 sides are different, I'll give you a little bit more time. I'm hearing a lot of digging around in those colored pencils. To try and draw a triangle, sometimes it's hard, I know, to draw a triangle that I don't know, sometimes I can visualize it and then drawing it is just hard. So try and do it where all 3 sides are different. But then we're going to write 3 sides are different just in case yours kind of looks like mine because mine is a little rough. Okay? And we call this a scalene triangle. Okay, so that's 3 different side lengths. That's a scalene triangle. Okay, if we have a triangle where two of the sides are the same amount. So I'm going to do that with the same color because those are the same. And one side is different. Okay? So two sides are the same. Or two sides are equal. What's another word for equal in math and geometry? Congruent. How do I show that the two sides are congruent besides maybe using the same color? Yeah, what are the marks for it? Yeah, we use the little lines. That shows that they're the same. So two sides are equal. This is called an isosceles triangle. So isosceles is goofy. I-S-O-S-C-E-L-E-S. Isosceles. Triangles are a very Greek thing. Greeks are really obsessed with perfection. Okay, so when we talk about like Pythagorean Theorem, that was from Pythagoras. Pythagoras was Greek. Okay, a lot of these theorems are going to come from ancient Greek. They were really obsessed with perfection, and triangles were very perfect to them because they found out a lot about the properties and how things will always work with them and a lot of the proofs. Okay, so when we see these words are Greek. That's why they're weird. I don't know, other than that. All right. On an isosceles triangle, the two sides that are the same are called legs. The two sides that are the same are called the legs. And the other side that's different is called the base. So we're going to be referencing that kind of a lot when we talk about isosceles triangles. Okay, we're going to be talking about the legs of an isosceles triangle or the base. Does the base always mean it has to be on the bottom? No, because if you look at this, is mine on the bottom? No. Alright, so we have three sides are different. Two sides are the same, one side's different. What's our only other option? Yeah, three sides are the same. So we could draw those tick marks in each one. We could do two, so that way we know it's not the same as that one. So that one is congruent to this side, which is congruent to this side. So three sides are equal. Alright, so for three sides equal, struggling on getting the camera on that, sorry. That's going to be called an equilateral.
Maybe you might want to mark or highlight that part that says equal, because that's a good reminder that equilateral means all are equal.
Lateral is just another way of saying like side. So equa is our prefix there that tells us all the sides are the same. How are we feeling so far? Decent? Not decent? Decent? I don't know. Ask Miss Ryder. Miss Ryder, someone out the restroom. Okay. She's at the... No. Alright, so one way to do the triangles is by side lengths. Our other way to do triangles is by the angle measure. So each triangle technically has two classifications. Sometimes we'll be classifying it by its side. Sometimes we'll be doing it by the angle. Sometimes we do both. Okay, and with angle measures, there are 4 options. Okay, so you need to draw 3 lines to make 4 columns. There's going to be 3, 4. There are 4 options for angle measures. Okay, I'll put the side lengths back up there if you need it later on. I want everyone to move on to angle measures right now. So I'll go back to the side lengths in just a little bit if you missed those. Okay, everyone do angle measures first, then I'll go back to side lengths. Alright, so we talked about... I'll bully you in the hallway. Alright, one type of triangle with angles we talked about was a right triangle. So this has nothing to do with sides, which means I'm going to put it in pencil. DC. Okay, and in a right triangle, that means we have one side that gives us that 90-degree angle.
So those of you just coming in, go about halfway down your page and put this angle measures with the 3 lines. We'll come back to the top half in a moment. We're about halfway down. Yep.
Okay, so one angle is exactly 90 degrees. So either we see the 90 degrees or we see that little corner. That tells us it is a right triangle. In a right triangle, we have some specific parts about the sides. Does anyone remember what one of the sides called in a right triangle? Yeah, the hypotenuse. Across from the 90-degree angle is always the hypotenuse. Okay, across from the 90-degree angle is always the hypotenuse. The other 2 parts are the legs. Alright, so that's if one angle is equal to 90 degrees. Then we might have a triangle where there is one angle more than 90 degrees. So it's more than that L. Think of an L. L is usually 90 degrees right here. L. This is bigger than the L. It would open up more. So one angle bigger than 90 degrees. Doesn't matter what the other 2 angles are. Okay, doesn't matter what the other 2 angles are. As long as I see one angle that's bigger than 90, it automatically becomes obtuse. So that one is bigger than 90. Kind of our main idea there is that it's bigger than 90. So that's obtuse. Sorry, I'm color coding as I go. Okay, so we have right, obtuse. What's the next one going to be? Acute. I have a really tough time drawing acute angles. I'm really good at drawing isosceles acute triangles, but not very any other ones. Okay, we're not going to mark any angles here because it's not necessarily that the angles are equal in any way. But the key here is all the angles are less than 90 or smaller than 90. Degrees. So all three angles have to be less than 90 degrees. That's called acute. So what's kind of goofy is with obtuse, all we need to look at is one angle. If we just see one angle is bigger than 90, we can say, yep, obtuse. But if I just see that there's one acute angle, I can't just say acute. I have to look at all the angles and check that they're all acute. Okay? Now this next one is technically an acute triangle. Okay, but it's a little bit more specific. This is going to be when all the angles are equal. Yep, that'd be a good idea. All the angles are equal. So I'm going to show that they are congruent by using, okay, I lied. I'm using another color. I did what Miss Snyder did. She's just amazing, so I always like to do what she does. Okay, to show congruent, we use those arcs. And if they all have that arc, that means they are all the same. Doesn't matter how I drew it because I marked it, and now it's official. Fun fact, you can draw whatever you want, but if you mark it, then it means they have to be the same, even if it doesn't look like it. Okay, so if all angles are the same, or all the angles are equal, okay, and the only way that they're all going to be equal is if they are all 60 degrees. So that's the only time that we will see all angles equal. We're going to use that prefix, equa, angular. That prefix equa really tells us that they're equal. Alright, so it's important. If you were here before and you got this written down, you can write this. I'll put this back on the board during practice time if you need to write the top part down. So don't worry about writing it down quite yet. Okay, but equiangular and equilateral are always together. If you see all the angles are the same, you can assume that all the angles are the same. I don't know what I just said. I was zoned out for a second. If you see all the angles are the same, you can assume all the sides are the same. Right? Is that what I said? I don't know. But you can always go between the two. You know that these always go together. Okay, the other ones, these can mismatch with any of these. So it could be obtuse isosceles, obtuse scalene. It might be acute scalene or acute isosceles. It could be a right scalene or a right isosceles. Those are all options. All right, when we classify angles or triangles, this is the last part that we're going to write in our notes. We always do the angle classification, and then we do the side classification, and then we say the word triangle. So it always goes angle and then the side triangle. So for example, we might say a right isosceles triangle. For some reason in English, we always put the angle part first. Okay, or it might be acute scalene. Okay, we won't write down all the options because there is 1, 2, 3, 4, 5, 6. There's 7 of them. It's just a lot of work. But you always put the angle first and then the side. All right, we're going to do a quick practice all together before you do practice on your own. Okay, if you didn't finish copying the notes, that's okay. I'll put it back on in just a